Welcome to this VulnHub walkthrough video. I'm hoping this will be the first in a series of walkthrough videos that I'll do of VulnHub VMs. The aim of the series for myself is really to practice my skills in pen testing, which is a fairly new field to me, even though I have worked in computers for a long time. Hopefully, if these videos provide any value for anyone else to learn any hints and tips along the way, that'd be really great as well. So if we go ahead and get started now, you can see here what I have. I've got my VirtualBox running on this MacBook here. And I've got a couple of VMs there. I've got my attacking Kali Linux system, and I've also got my vulnerable VM there, which are both up and running. So here you can see my vulnerable VM, which is up and running, which I'm just going to minimize away. And here we have our attacking machine, which I'm going to go ahead and full screen and log in there. Both of these systems are set up on bridged adapter, so they've actually got IP addresses on my home network. So let's go ahead and log in. Okay, so the first thing I have to do is just double check what IPs these systems have actually got. So you can see there the attacking machine is on 213. And I'm also going to use this small ping sweep script, which you can see there, just to scan the 192.168.1 range for what other systems are up. So you can see there, because we're on my home network, we've got quite a few systems referenced. The one we're interested in, which is the vulnerable VM, is the 212 address. So at this point now, we're ready to do some scanning of the ports to see what services are actually up and running on this vulnerable system. So for that, we're going to use a tool called Nmap. I'm just going to paste in the command here and make sure that I specify the correct target IP. And for anyone interested, these few options I've added here are really just to make sure the output is very verbose and there's lots of detail in the information which comes back to me. That it tries to identify and detect the operating system which is running on the system it's scanning. That it scans in a particularly fast mode, which is 4 out of 5 in terms of speed and aggressiveness. And also that it's trying out some default scripts when it finds particular services running on ports, and does the default TCP SYN scan or half scan, so it's relatively stealthy, as you might say. So we'll go ahead and run that scan. And we'll see straight away we've got a couple of services coming up, actually 3 services on 3 different ports there. So port 80, so that's likely a web server of some kind running. Port 22, which is probably an SSH service, which we can check in a moment. And also a service running on 1898, which we're not sure about yet. We can certainly dig into that a bit more. Okay, so first of all, I'm just going to go ahead and see if we can SSH to that port 22. Okay, so we're being prompted for a password, and obviously that's kind of as far as we can go there, but it does look like it's a SSH service up and running, which we can potentially maybe try brute forcing later if we find some potential usernames to work with. Okay, so now let's open up Firefox and have a look at the browser. And we'll have a look at that port 80, which is open on the system. Okay, so this is the page we're being presented with. Let's see if we can maybe have a look at the source, see if there's any interesting there. It's kind of bouncing this to the same image. Let's see if we've got a robots.txt file maybe. No, being passed to the same. An admin directory. We're not really getting much further than this. Here, what we could also maybe do is do a Dirbuster scan. Of that system. Let's see what arguments it takes first. So URL and then the word lists and any options. So we'll go. Let's go and clear that. DIRB, HTTP 192.168.121, and then we will use the word lists already on the Kali machine, and we'll use one called common. And we'll leave that to scan, see if it comes up with any other interesting directories. And it's returned pretty quickly, saying it couldn't connect, and actually found no information for us. So I'm going to move on from that one now, and maybe come back to it. And I'll just look at the final port now, which we found there to be some kind of service running on it. Which was 1898. Okay, so here we do have a web page which has got a login area, the ability to create a new account possibly. We've got a couple of posts made by a Tiago, so we might have a potential username we could use there as part of our attack. Let's go back and look at the other comment. Talking about posting an MP3 file maybe. And we've got a different potential user account called Ida there. And at the bottom we can see there, this is powered by Drupal. So I'm quite interested now to see exactly what version of Drupal is running and whether there's anything we could do to explore this further. So let's go ahead and just see if there's a robots.txt on this one. Okay, so this one's got a pretty decent amount of information for us now. You can see there's reference to an admin link there, user directory, a change log, which could be quite useful for us. And then a few other folders, scripts, profiles, themes. So let's go ahead and maybe start with this change log. This is probably a pretty good place for us to find out what version of Drupal is actually running. Okay, great. So you can see right at the top there, it looks like it could be Drupal 7.54. So we've got a good bit of information now, which we can actually take away online and see if we can find anything interesting about that. So let's just Google the Drupal 7.54 exploit. I'm going to actually have a look on exploit.db to see if there's anything referencing that version of Drupal. Am I a computer or am I a human being? Go ahead and search that. Okay, so we had version 7.54. So potentially we've got some authenticated remote code execution vulnerabilities, which would be really good. This one here covers quite a few versions. Let's have a look at this one. It's a Ruby exploit. So potentially we could download this Ruby file and just point it at our vulnerable target and see if we can exploit that Drupal application running on it. So let's go ahead and download that file. I'm just going to copy that over to the desktop. And then let's go ahead and run that script. See if it tells us about how to actually use and target that. Okay, so it's just giving us a target example with a full kind of URL format. So let's give it HTTP 192.168.12.12 and that port number. And fire it off. Okay, so it looks like we're getting some good feedback there, good news. Target is exploitable and wrote to the web root. And now we have a fake shell. Let's do a quick ID, see who we are. So we've got a low level privileged shell on the system now as the web service kind of user. So let's see what else we can do. Let's have a look whether we can browse into particular directories. Let's move over to the temp directory. It doesn't look like we've got permissions to actually navigate around. Let's see if we can read some files of interest. Let's have a look if we can have a look at the password file to see what user accounts are on the system. We can, which is good. So again, we see that Tiago, which came up in our web page as well. So that's the username we might want to be able to use to brute force the SSH maybe. Also looks like it's running MySQL, which is another area we could dig into maybe. Nothing else jumping out at the moment. Let's see how the permissions are set up on the system. Let's see if I can just query the shadow file for the hash values of the user's passwords. Permission denied as we'd expect. Okay. Right. So at this stage, I'd like to find out a bit more about the system I've landed on and work out what potential exploits I might be able to run against the version of the kernel running, or the version of the operating system, or any other services. So to do that, I've got a few scripts that I like to run. I bring up the CTF folder. So a few of these are here. One of them is called linenum.sh. One's called Linux priv checker, which is a Python script. And there's also Unix privesc check. So there's a few different flavors of these scripts. Each might give you slightly differing results, but any of those could be useful for me. There's one I actually found recently, which I'm going to use in this case. Which we can download now. So it's called Linux Exploit Suggester, which is available on GitHub here. So I'm going to go ahead and just download that file. And I'm going to extract that to the desktop as well. Okay, so here's that bash script file, which I'm going to try and upload now to our system and see if we can find more out about the vulnerable system using that command line that we've got. Okay, so first of all, let's get into that folder. and I'm going to move that file to my web directory on my attacking machine. Under var www.html. And I'm also gonna just open up the permissions on that file, just so we don't have any issues with picking it up. Because I'm lazy, so I always just open up the permissions like that, which is probably a bad practice. Okay, that's now done. And now on my vulnerable system on the left, I'm just going to see what tools I could have made available for myself on the system. Let's try wget, let's see if that is there for me to pick that up. So that's great. So we're going to go ahead and use that. So I'm going to do http 192.168.1.213, so this is now pointing back to my attacking machine. And I'm going to pick up that script and download that. So that says connection refused. It's quite possible that the web service isn't actually up and running on our attacking machine yet, so let's go ahead and do that. Spell it right would be useful. Okay, and now let's go ahead and try and pick up that file again. Great, and that's now worked. So if we have a look at that, we can now see our Linux suggester file sitting there. Okay, now what I'm going to do is I'm going to go ahead and I'm going to move that Linux exploit suggester file to the temp directory. And I'm also going to open up the permissions again. I'm going to go ahead and run it. And I'm just going to output the results to a text file within the temp directory. Okay, so let's just check that that output file has actually appeared. It has. It's got a little bit of data in. So let's go ahead and read that. See what we've got.
I just couldn't get it. So I refused to call her mother. I called her lady. And she accepted that. I learned that love heals.
Okay, actually didn't quite run it right. I spelt it incorrectly. There we go. Let's try again. That's better. It's actually taking a couple of seconds to run there. I've got much more data in there now, which is looking better. And let's have a look at the content. Great. So you can see at the top it's telling us what version of kernel that we're working with. 32-bit architecture, Ubuntu 14.045, and then various possible exploits that we could try. Now, the first time I went through this, using this script and other privilege escalation scripts, there's a lot of different exploits I actually uploaded to the system and tried with no success. And I was actually quite surprised to actually find one when I did find that it worked. It was one which I didn't expect was going to work. This one in particular was the Dirty Cow 2 here. So the reason why I thought this was quite strange is if we actually go and have a look at this exploit on the ExploitDB website. So we'll close a few of these windows which I've opened up everywhere. Okay, and let's have a look at the exploit itself on the website. So here it is. Now, the reason why I was surprised this kind of came up in the list of potential exploits we could use is because it's saying that it's for a Linux kernel version of 2.6.22 to 3.9. And as you might remember, the system we're working with here, the vulnerable system, is 4.4.0. So I was actually quite surprised that this would work at all, because it actually looks like we've got a different version of the kernel which then is being talked about. So I thought I'd have a quick look at the script itself. To see why it might be suggesting that to me. So let's scroll up and find where it's doing its kernel checks against the different operating systems, which is around here. In fact, rather than dig through manually, let's count that again. Let's grab the output for Dirty Cow, and let's do 3 lines around it either way. There you go, that's a bit better. So it's the lower area we're looking at here, and particularly there. So the script is actually checking whether the kernel version is between 2.6.22, which matches what we're seeing on exploit.db, up until versions 4.8.3, which differs to what we're seeing on the website. So the script is well aware that it actually may work on versions higher than advertised here. So that's why I ended up giving it a shot in the end. So this particular one is a C++ exploit, which I'm now going to go ahead and download. Actually, are we on the same number there? Actually, no, it's slightly different exploit page. Let's see, 4.7. There we go. Still says the same kernel number versions. This is the C++. And it's also giving us a bit of information in the comments there about exactly how to compile this and how to run that. So I'm going to go ahead and download that C++ file now. So let's go into our downloads. And I'll just stick it on my desktop again. Let's bring this back into play. Right, okay. So same as last time, what I'm going to do is just back up onto the desktop, find my exploit file, which is CPP there, and I'm going to move that to my web directory. I'm also going to change the permissions on it again, open them up. Okay, so let's go ahead and from our vulnerable machine again, let's clear the output. Can't do that. Let's go ahead and let's pick up that file. So we've picked that up successfully. See that now in the directory there, and again I'm just going to move that file over to the temp directory, which I'm hoping I'll be allowed to execute from, and I'm lastly going to change the permissions that file and open them up again. Looking in the temp folder now. Yeah, that looks executable. So that's all good. The last thing I want to do is actually give myself a bit of a better shell to potentially run this exploit from, because I'm kind of working in what it was referred to as a fake shell earlier on the left at the moment. And if we just try and do a SU command there, you can see it says must be run from terminal, because we're not actually in a proper terminal there. So what I'm going to do is I'm going to upload another file now, and we're going to actually try and get ourselves a interpreter shell within Metasploit. So I'm going to start Metasploit in this lower right hand corner. And in the upper right hand area, I'm going to use MSF Venom to create my Linux 32-bit interpreter reverse TCP payload. So that's going to report back to my correct IP on port 5555. That's all fine. So I'm going to go ahead and make that now. So let's output that to, let's call that new shell. .elf. Great, you can now see that executable there. And again, I'm going to move that over to my directory for my web browser. Again, it might be unnecessary, but I'm just going to change the permissions again, just to make sure. And I'm going to pick that up from my vulnerable system again. Okay, move that into the temp directory. Make that executable. So that's now ready to go, but I'm just going to set up my handler in Metasploit in the lower right area to accept that incoming connection. So to do that, we're going to use the multi-handler. We're going to make sure that it knows that incoming payload is a Linux 32-bit interpreter shell. Set up our own IP, and finally tell it what port to listen on. And now we can go ahead and run that listener. Perfect. So back on our vulnerable system on the left now. Let's go ahead and see if we can get this new shell up and running. Great, and you can see in the bottom right hand area now, we've got that information coming in, and we now have a interpreter session which I can drop into a shell. Still the same level of privileges. But now it's actually a proper shell. Okay, so at this point I'm kind of ready to see if that exploit works. So let's go over to our temp area, just check everything's looking good in there. Yeah, so the next thing we have to do is compile that exploit. So I'm just going to copy over the compile command that we found in the instructions of the exploit, which is there. So this is going to create an executable file called decal. It doesn't look particularly good. Has it actually made file? No. double check we've typed that in right. Let's get over to our temp directory. Kind of looks okay there. Getting lots of errors again. Whether G++ does look like it's installed. I wonder whether we'll have any more luck just running it from the interpreter level. Back into that shell, let's just do a quick check of the details of the CPP file. So let's do an MD5 sum of this 4.47.cpp, which is 4473 in size. Let's have a look on our desktop. We put it in our directory there. Interesting. So the file that we have sitting in our web directory is actually significantly bigger than the one we're working with on the remote system. So potentially something went wrong in the transfer there. So let's maybe try and pick that up again. So let's do a wget http 192.168.1.3.4.0.47.cpp. Let's have a look at that. Okay, so now the file size looks much better, actually. So rename that one and work with that one. I think that's going to do much better for us. Not sure what happened with the first file transfer. Let's call it decal.cpp. Let's also change the permissions. Let's have a look at that. Okay, that's much better. Great. So now let's go ahead and try and compile this again. So decal.cpp -util. Okay, that's looking better now, absolutely. Yeah, so we now have a decal executable there, which I'm going to go ahead and run on the system as instructed in the exploit comments. Great. And we now have a root shell on our system. So we started with scanning the host. We got low-level privileges on the system. We did a bit more reconnaissance about what we might be able to leverage. elevated the quality of our shell, and then actually elevated ourselves to root level privileges on the system using that dirty cow to exploit. I'm sure there's a number of other ways you could have completed this system. I'd love to hear in the comments about some other vulnerabilities on the system that you guys found, or other ways which you got to root, and also whether you've got any comments about why that dirty cow 2 exploit actually worked even though the kernel versions didn't slightly match. Okay, thanks very much for watching, and we'll see you next week.